All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing another study stream. Give me a second. Let me just turn down the volume of that background sound that I had set up for myself. Um, okay, done. So, yeah, we are going to be doing another study stream. In the last stream, we did what did we do exactly? In the last stream, we took a look at the async IO library, or I guess the async IO module, because I guess we would say that the async IO module is part of the standard library in Python. I don't know. I'm gonna have to confirm my terminology, but you get the point. We did a bunch of stuff with, or well, we looked into the basics of async IO. And hold on, give me a second. Let me just place my mic properly. Okay, so my my intent with learning the basics of async IO was to do two things. One, be able to do basic async methods, so coroutines basically, and also do async socket programming, async networking, let's say. Um, Actually, that's what it is, async networking in Python. And then I think, what was it? Maybe towards the middle of the last stream or towards the end of the last stream. I don't remember. I eventually also looked into the select class, which allows you to use methods like select and poll to check if there's any data available to read on the socket. So this tends to be another way of doing things asynchronously, but you're not really doing it asynchronously, or well, you're not doing it asynchronously in the conventional sense, but in a way it is asynchronous in the sense that the way that you're going about doing it is not causing the main thread to get blocked. So the way that it works is you first check if there's data available to be read. You either use select or poll for to accomplish that. You check if there's data available to be read. If there is data available, then you call your receive method, because the receive method blocks the main thread. So yeah, that was the idea. I was reading up more on the select class after the stream, and at some point throughout my research, I discovered another class called the selectors class, which is apparently a high level class built on top of, well, I don't know if it's necessarily built on top, but it's more higher level than the select class. I didn't know this. Apparently, the select class, it mentions it somewhere over here. Yeah. So apparently, the select class is more low level, and the selectors class is it's higher level than the select class. So then I started doing research on the selectors class. Oh, yeah, it says built upon the select module primitives. This module also, no, this module allows high level and efficient IO multiplexing built upon the select module primitives. Users are encouraged to use this module instead unless they want precise control over the OS level primitives used. And for my purpose, I did not require low level control. So I decided to go with this instead. And so then I started doing research on how exactly I'm supposed to use this. I'm still not all the way there yet. There's still quite a bit more that I have to learn about this, but so far this is what I've understood about the workflow. So you create your socket, and then, okay, so let's say we're talking about a server socket here, and this is all UDP. I'm not doing I'm not doing stuff in TCP. In fact, that was actually one of the things that uh, I wanted to do in async IO as well. But to do UDP asynchronously using async IO, you would have to take a slightly different path because the support wasn't available for it out of the box. It is kind of available, but on a lower level. They don't have like higher level methods for that. So you kind of have to build your own little framework on top of what they have available. They do have something available for UDP, but like you kind of have to build on top of that. Uh, I didn't want to do that. I wanted to go for I wanted to go for something simpler because what I'm trying to do does not require too much complicated stuff. I just wanted simple non-blocking. Actually, non-blocking sockets is kind of how I got to select and selectors. I think I'm remembering. I think I'm remembering it now. I was wondering that. Okay, so we are able to set we're able to set a socket to be non-blocking, but then I couldn't understand exactly how you go about using a non-blocking socket. Like, how is it non-blocking? Turns out you have to use stuff like select and selectors and all of that. Let me let me think about that. Hold on. I haven't thought about it until just now. The okay, so it's a non-blocking socket. Let's say it's a blocking socket. Okay, I don't remember the specifics around that. Because no, I mean, I just said that in order to use non-blocking sockets, you would have to use, you know, select and poll and stuff like that. But then, couldn't you also do that with blocking sockets? Or is it that select and poll only work with non-blocking sockets? Okay, I don't remember, so I'm not gonna. Oh, actually, no, I don't know. So I'm not gonna give information on that. I'm gonna do research on that later. But this is where we are at now. I'm using non-blocking sockets, and then I'm using the selector class in order to create an instance of this default selector. After we've created the selector, we register the socket with the selector, and at a later time, we can call select on this instance to see if there's any data available. So select returns it returns a list of tuples. Hold on, let me let IntelliSense show up. Okay, well, I mean, I'll tell you what. Okay, there it is. So it returns, if you look here, it returns a list of tuples, and the tuple contains a selector key and the event mask. So the event mask can be read or write. In my case, it's read. And the selector key is basically, how do I say this? It's a key that represents the file descriptor, or it's a key that represents that thing that you registered. So here, I'm able to do something like this, where I access the first element of the list in poll res, which contains the result of select. And in that, I'm accessing the tuple. The tuple contains two elements. So I'm looking for the first element, which is a selector key. And in the selector key, I access the file object. In this instance, the file object, because the selector class can be used for more than just sockets, but I believe on Windows only sockets are supported. I don't remember. I'd read it somewhere. I think because like the behavior here is platform dependent, but on Windows I believe it's only sockets supported, which is great because that's exactly what I'm looking for, right? So I access the selector key, and on the selector key we have a couple of different attributes. One of them is the file object, which basically represents whatever you had registered, which in my case is the socket. So because it's the socket, so I can then call the receive method on it. Even though the method is appearing white here, I think it's because it's not able to figure out exactly what, which, I mean, that makes sense, right? It can't guess what data is going to be coming in, but I know what data is going to be coming in. So I'm able to, I know that there's a socket coming in. So that's why I'm able to call the receive method here. And this is great because now I'm able to make it so, oh, I don't know if I mentioned this. All of this is happening within a while loop. Give me a second. Okay, so all of this is happening within a while loop, meaning I could move this code into, let's say, an OpenCV loop. Because like when you create GUI with OpenCV, in order to have that window still displaying, you have to actually. Do you have to? Yeah, I think so. I think so. In order to have the window still displaying, you have to run a while loop just so that the thing remains active. Otherwise, it's gonna display, and then it's just gonna exit the program. It's gonna exit the script. So basically, you have to have the whole point of saying this is that you have to have a while loop, and what I can do is I can move this code into that while loop. I'm gonna have to check on certain specifics, stuff like timeout, for example, because like the select method here has certain things. It mentions here if timeout is greater than 1 or greater than 0, this specifies the maximum wait time in seconds. If timeout is less than or equal to 0, the select call won't block and will report the currently ready file objects. And if timeout is none, the select call will block until a monitored file object becomes ready. So in my case, I need it to be 0 or less than 0, and that's exactly what I've done here. Dude, I still need to go back and check because earlier I had mentioned this thing about non-blocking and blocking sockets. At some point, I should test out what happens if I set, because if I remember right, the blocking methods, or well, set non-blocking or set blocking methods, they had something, they were shorthand methods, or that method was shorthand for calling set timeout. Let me just go back and look at the socket thing again. Is sockets mentioned somewhere here? Let me just I don't think so. So let me look it up separately. Because I'm suddenly curious about that thing that I was talking about with like non-blocking and stuff. All right, we've got socket here. Let's open that up. Okay, now here I need to look for set, what was it, set blocking? Yeah, there it is. A generalization of this based on timeouts is supported through so and so. Non-blocking mode is supported through set blocking. Okay, set blocking or non-blocking mode of the socket. This method is a shorthand for certain set timeout calls. So if set blocking is true, it's equivalent to set timeout none. And if set blocking is false, it's okay. Isn't this similar to select over here? Because like select mentions that if timeout is greater than 0, actually, no, let's keep greater than 0 aside for a second. It mentions that if the timeout is less than or equal to 0, then it's a non-blocking socket, or at least the select call is not going to block. And if the timeout is none, then the call will block until a monitored file object becomes ready. In this case, the file object is the socket. Dude, I need to look into this. I need to look into the blocking and non-blocking thing, and I feel like I need to understand it on a level lower than Python. I feel like that would help me. I feel like that would help me more. Either way, so I have my basic my basic loop set up. Um, is it running? Yeah, I ran it earlier. So here's what I'm gonna do. I'm gonna remove. We can get rid of this other code, but I'm still glad that I did the async stuff, because I'm gonna be using async for Twitch IO. Now that I have this async thing set up, I can now do Twitch IO related stuff with it. And I'm kind of tempted to maybe make like, so earlier, actually a while back, before Twitch released their Unity game engine plugin, I was planning to, and like this was like, I was already in the process of doing it. Like that's how, like I found out about the plugin just in time before I ended up putting a bunch of effort into making a middleware app. What I was going to do is I was going to make a middleware app in C sharp, which basically used TwitchLib in a C sharp console app, and then so it would use TwitchLib and either read chat commands or read, let's say, certain, what are they called, channel point redeems, and based on what gets read, based on whether it's a redemption or a chat command or whatever, it would then pass the relevant message over to uh, over to my VTubing app, where I would then do something with it. So that was the idea, but then the Twitch game engine plugin, it kind of simplified that. It made that process a little simpler, because then I didn't need to have a separate middleware app running. However, I still wanted to explore Twitch IO, just because I was just interested in it. I feel like I can do some interesting stuff with that as well. So I kind of want to explore Twitch IO. Actually, now that I'm talking about it, let me just bring it up real quick. Uh oh, okay. Yeah, that's fine. So we can do this and that. So this is great, because this will give me an excuse to play around more with stuff in Python. And I do have certain ideas for things that I wanted to do. Certain Twitch related things that I wanted to do in Python instead of doing it in C sharp. Because like, I mean, TwitchLib is very feature rich. Like, dude, huge shout out. Each time I mention it, I have to give a huge shout out to all the devs that have been working on TwitchLib, because they've made a very feature rich library that that makes it easy for us to interface with the Twitch API. Like we don't have to worry about the implementation details. All we have to do is call a couple of methods, hook into various like events and stuff, and we are good to go. There's support for various things like calling the Helix endpoints using using PubSub. I think Event Sub is available, but there's a different way to go about using it, which is why I never actually went into Event Sub, but I did look into PubSub. There's also IRC support, like out of the box. Even with IRC, it's just you have to create a class and call a couple of methods and you're good to go. Further from that point, you can start building your own functionality into it, which is why I'm glad that some devs actually they put the time and effort into building this kind of a library, because this way we don't have to worry about the implementation details. We can just use these libraries to build stuff that we were intending to build. We don't need to spend a whole lot of time first building the library and then building what we wanted to build. We can just build what we wanted to build using these libraries. And it's the same thing with, I'm assuming it's the same thing with Twitch IO as well. In fact, I think the first time I had, I'm trying to remember, because like, I think the first time that I'd heard about Twitch IO was either when I raided someone or when I was just stream hopping, and I landed on this stream where this person was they were coding, I think, a chatbot. I think it was a chatbot. I don't remember. But yeah, I think they were coding a chatbot, and they were using Twitch IO for it. Like I found out about Twitch IO through them. And then I looked it up and I was like, yeah, dude, at some point I should look into this as well. Okay, so it mentions here full asynchronous design covers 100% of the Twitch API, IRC commands extension for creating powerful chatbots. I haven't understood the concept of extensions here. Like they've mentioned extensions more than once. I don't know if they've mentioned it outside of the context of IRC or not, but yeah, I need to look into what exactly they mean when they say extension. They say IRC commands extension for creating. Hold on, let me look it up on. Let me see if extensions mean something in Python. Python extensions. Many extension modules just provide new functions and types. Uh, this is talking about extending Python with C or C++. So that's probably not what I'm looking for. Extending and embedding the Python interpreter, also not what I'm looking for. Okay. I guess I'll find out later. Okay, so there's IRC support. There's event sub and pub sub support. There's helper extensions for music/sound and background tasks. That's interesting. Hold on. Let's open this up. I think here. I think this is the one. So let's open this up, and there might be a requirements thing. There it is. So requirements shows you which modules are in use by this module. Or, well, no. Which modules are currently installed in this environment, I should say. Actually, if that's the case, then am I really going to get the information I'm looking for? I don't think so. Well, I mean, okay, so so usually the requirements.txt file gives you a list of all the packages that you need to install in order to use this package that you are currently trying to install or currently trying to use. So this requirements.txt file would be required or would contain the list of packages that need to be installed in order to run Twitch IO. So here it mentions all of these. It's only 3 though. What am I missing here? Because, okay, the reason I'm curious about this is because it mentioned music and sound. Python doesn't have, at least to my knowledge, it doesn't have support for music and sound and stuff. Like out of the box, I mean. You can use other libraries to do that. Actually, wait, no. Wait, hold up. There was a wave. Hold on. Was it playing audio that's not supported or recording audio that's not supported? Let me just look that up so I'm not giving wrong information. Because there was something audio related, but despite that, I needed to use something else in order to be able to read audio files and play audio files and stuff. Okay, so there is a Wave module which provides a convenient interface to waveform audio file format. Uh, there's a thing for opening wave files. There's a thing for, so you can close, you can get various details, you can read stuff. You can also write stuff. But there's nothing for playing as far as I'm seeing. Like you can read the data, you can also write data to it, but there's nothing to actually play the file. Okay, so yeah, that's kind of why I was wondering how you go about. Okay, so they have examples. They have an example section. Let's take a look at the example section. There's basic bot, basic routine, and there's also an example for event sub. So let's take a look at that. This routine will run every 5 seconds for 5 iterations. That's interesting. We can just create this. What is this thing? Let me look that up. Python @property. This is a built-in decorator for the property function. Okay, I don't think I've looked into decorators in Python. At some point, maybe I should look into that as well. Because I remember this coming up ages ago, but I just didn't look into it because at the time I didn't need to. All right. So a decorator is a function returning another function, usually applied as a function transformation using the wrapper syntax. Common examples for decorators are class method and static method. The decorator's syntax is merely syntactic sugar. The following two function definitions are semantically equivalent. Wait a minute. So f equals static method f. Hold on. What is going on here? So we define the function f, right? And then this is the function, but then outside here we create a variable called f and assign static method f to it. How does that work? Like, what is going on here? Okay, let's open up class method and static method. Maybe I need to look into these to understand them better. By the way, real quick, there is an ad break coming up. So I'm gonna run a 30-second ad now, and I'll see you guys in 30 seconds. All right, welcome back. So, uh, I was looking into class method and static method. Okay, so static method transforms a method into a static method. A static method does not receive an implicit first argument. Oh, it doesn't receive an implicit first argument of self. Okay, okay. Uh, to declare to declare a static method, use this idiom. Okay, all right. The static method form is a function decorator. See function definitions. Hold on. Does this lead to the glossary or somewhere else? No, this leads to the glossary. Let's take a look at function definitions and see if decorators are mentioned somewhere here. Does this also lead to the glossary? I don't think so. Oh, this is just showing the syntax. Okay, okay. All right, so a static method can be called either on the class or on an instance such as so and so. Yeah, okay. Yeah, that's your basic static method. Moreover, the static method descriptor is also callable. What's a descriptor? Wait, so it can be used in the class definition such as so and so. Let me open up this thing. What's a descriptor? Any object which defines the methods get, set, delete. When a class attribute is a descriptor, its special binding behavior is triggered upon attribute lookup. Normally using a b to get, set, or delete. Normally using a dot b. What does that mean? Okay. To get, set, or delete an attribute, looks up the object named b in the class dictionary for a. But b is a okay, dude, I'm not gonna go into this right now. Uh, Static methods in Python are similar to those found in Java or C++. Also, okay, hold on. I don't want to just leave that, even though like I'm not completely understanding uh, what descriptors are. I need to spend some time reading up on descriptors. Descriptor guide. There's a whole guide for this. In this method, no, in this primer, we start with the most basic possible example, And then we'll add new capabilities one by one. The 10 class is a descriptor whose, with the class is a descriptor, okay, whose get method always returns a constant 10. Okay, to use the descriptor, it must be stored as, oh, I think I remember this. Hold on. Hold on. I think I've seen this happening when I was doing MicroPython stuff with ESP32, because you are able to call the classes as if they were functions. And when that would happen, I was confused about what exactly was happening internally. Like, were we like reinitializing the object? Were we calling the constructor again? I don't think that was the case. I think maybe we were calling get. Okay, to use the descriptor, it must be stored as a class variable. It must be stored as a class variable in another class. This is the descriptor instance. An interactive session shows the difference between normal attribute lookup and descriptor lookup. A equals so and so. A dot x is a normal attribute lookup, and A dot y is a descriptor lookup. The A dot x attribute lookup, no, in the A dot x attribute lookup, the dot operator finds x with a value of 5 in the class dictionary. Okay. In the A dot y lookup, the dot operator finds a descriptor instance recognized by its get method. Calling that method returns 10. Note that the value of 10 is not stored in either the class dictionary or the instance dictionary. Instead, the value 10 is computed on demand. All right. This example shows how a simple descriptor works, but isn't very useful. For retrieving constants, a normal attribute lookup would be better. True. In the next section, we'll create something more useful, a dynamic lookup. Okay. Interesting descriptors typically run computations instead of returning constants. Okay. All right. So what's going on here? We have a descriptor being implemented. Is that how we would say it? Yeah, we are implementing a descriptor, right? The class has a get method that makes it a descriptor. And then in the directory class, we are creating an instance of the descriptor. Okay. And then this is a regular instance. So this is like an initialization thing. Okay. An interactive session shows that the lookup is dynamic. It computes different updated answers each time. Yeah, it's probably dynamic because of, wait, hold on. No, back up. So we have obj over here and we have directory name. So when we pass in this, how is obj being passed in? How does that work? We have obj and obj type. In directory, we are passing in a directory name, and then we are assigning, is there more code here that I'm not seeing? No, there's no more code. So our obj and obj type, just like they have certain meaning. They're not just random variables that have been created. Because then that would make sense, right? In that case, when this descriptor is being called, with the descriptor, there's going to be an object value passed. That object is basically an instance of whatever class this descriptor is being called from. And then because of that, we are able to access obj.directory name, which is here. And that's kind of what makes it dynamic, because then when you create an instance of directory with different names, with different directory names, those different directory names are passed in here, and the descriptor gives you different values. Okay, all right. They haven't mentioned anywhere what exactly obj means, or did they mention and I just missed it? Oh yeah, I didn't notice this earlier. It's over here as well. So is this basic descriptor syntax that you have self, obj, and obj type? Let's open the thing up here. We have get, set. Maybe I should look at get. Yeah, that'll probably mention. So there's self instance. Oh, okay. So that's how it is. So these are the arguments that get passed in, and you can name it whatever you want. So you have self, and then you have the instance name, which you can name it whatever you want, and then the owner also you can call it. Actually, I wonder why they were calling it obj type, because like I thought that meant something else. Okay, let's read this. So get is called to get the attribute of the owner class, the class attribute access. Wait, it's called to get the attribute of the owner class or of an instance of that class. Instance attribute access. Okay. The optional owner argument is the owner class, while instance is the instance that the attribute was accessed through. Okay, okay. Or none when the attribute is accessed through the owner. Okay, all right. Okay, this is interesting. This is actually pretty interesting. The obj parameter is either G or S, an instance of directory. It is the obj parameter that lets the get method learn the target directory. The obj type parameter is the class directory. All right, so then we have managed attributes. A popular use for descriptors is managing access to instance data. All right, okay. We are not going to go too deep into this. I've kind of understood what descriptors are, or at least I have a basic understanding of descriptors. What what led us to this? We were in decorators. How did we get to descriptors? Moreover, the static method descriptor is also callable. Static method is a The static method descriptor is also callable, so it can be used in in the class definition, such as so and so. Oh, does that mean that within the class you can call this function? Like within this C class you are able to call this function? Like, is that what they're saying? All right, so then we have class method for a variant that is useful for creating alternate class constructors. Like all decorators, it is possible to call static method as a regular function and do the same with and do something with its result. Method equals static method. Wait, how would this work? Like, what exactly would this be doing? Wait, let me read that again. Like all decorators, it is also possible to call. Is the music still going? Nope, the music stopped. All right. Now, where was I? I was, I think, here or here. No, here. Okay. Uh, where was I? This is needed in some cases where you need a reference to a function from a class body and you want to avoid the automatic transformation to instance method. For these cases, use this idiom. Uh, okay, I'm kind of getting it, but like also kind of not getting it. This transforms a method into a class method. Right. So, okay. Now, what I'm curious about is over here. Where was it? I think it was here. So routine dot routine. I think I can find the routine. I'm not even sure what it is. Is it a class? Let's open up extension, routines. Okay, so let's open that. In that we have init. Okay, so I need to get a basic understanding of how this what do they call this? This decorator syntax, how exactly this works. I need to get I need to get kind of a basic understanding of it. Um, the decorator syntax is merely syntactical sugar. The following two function definitions are semantically equivalent. So we define a function and then set that as a static method. Okay, so then this, we would be defining this in a class, right? So we could do something like, okay, let's create a new thing here. I think I have to create the, I think I have to create it like top down, right? Just like just like functions, like you can't just define the function anywhere and expect to call it. Let's say I don't know, def something or one and pass. So I cannot call something o1 before it has before it has been defined. Give it a second. Let IntelliSense do its thing. Okay, let's wait for IntelliSense to tell me that I'm wrong. I think that's much better. Uh, okay, it's it's doing its thing. While it's doing its thing, I guess we can read. You know what? Let's also try searching for this wrapper syntax. curses.wrapper. Python function and curses, terminal handling for so-and-so. Okay, that's not what I'm looking for. Uh, yeah, it's probably not. Nope, not what I'm looking for. Uh, Let me just change my search. Python at symbol. Let's search for that, and let's search on Stack Overflow. Oh, I was also looking for this, right? So there is our error. It is not defined. Okay, great. Awesome. So here we're going to create a class. Let's say some class. What did I just do? Okay. Is it fine now? Oh, wait, what happens if I declare the same class multiple times? Because I remember that being an issue a while back, something similar being an issue a while back, where I would create a certain type and then I would run into an issue where trying to do it again would throw an error. Okay, so I'm not getting that issue here. So that might have been something else that I'm remembering. What was I going to do here? Yeah, def, let's say some func 01, and this returns 5. Okay, great. So what was I gonna do? Wait, what's the problem? Expected this. No, okay, we're good. So we could do something like this. Would that would that work? Would that be a thing? So then we can do some class O1 dot some func O1. There it is. So we can do that. Now let's say I'm calling this here, but I comment this out. Are we going to get an error here? No, I'm not getting an error. What if I do this? Let me just run this anyways and see if it's... Well, this shouldn't work because there's nothing to pass into self. If I'm calling this as a static method, there's nothing to pass in as a self parameter. Whereas if I was calling this method, if I was calling some func O1 on an instance of some class O1, that instance would then get passed into self. Wow, this is running for a bit. All right, give it a second. It's missing the parameter. Okay. All right. Let's remove that and try running it. Okay, this works. Okay, just real quick, I'm going to change the names here. See if it still works. Yeah, it still works. Okay. So then what is the idea behind static method? If I'm able to access the method just by itself without a decorator, what's the idea behind static method? The same concept exists for classes, but is less commonly used there. See the documentation for function definitions and class definitions for more about decorators. Okay. Yeah, I'm not getting it. Oh, you know what I should look up? Python custom decorator. All right. Somebody asked this question and then somebody else answered it. So give me a second while I look this up. Python custom decorator. Okay. Um, okay, writing custom Python decorators and the magic of how they init. Okay. How to create custom decorator in Django. What is Django again? I've heard that name before. Django Python. The web framework for perfectionists with deadlines? Dude, what? Um, Django is a free and open source Python based web framework that runs on a web server. It follows the model template views architectural pattern. It is maintained by Django Software Foundation, an independent organization of so and so. Okay, all right. So it's a web framework. Okay, let me open up the GitHub for it. It just says that it's the web framework for perfectionists with deadlines. This is a high-level Python web framework that encourages rapid development and clean, pragmatic design. Thanks for checking it out. Right. Okay. I have other stuff to do, so I'm gonna look into Django later. For now, we're gonna look into this. How do I make function decorators and chain them together? Somebody was mentioning here. I think somebody was explaining here. Yeah. Wow. Voice crack. Take a good look at this enormous answer slash novel. Okay. Let's take a look. It is one of the best explanations I've come across. The shortest explanation that I can give is that decorators wrap your function in another function that returns a function. Decorators wrap your function in another function that returns a function. It's returning a function, meaning whatever is being returned can be called. Okay, how does that? I mean, there's use cases for that as well, but like, I was about to ask, how does that help? But yeah, there's use cases for that. Decorator basics. Python functions are objects. To understand decorators, you must first understand that functions are objects in Python. This has important consequences. Let's see why. So we have a function called shout. We can call the function and get the output in print. Okay. And then as an object, you can assign the function to a variable like any other object. Okay. Notice we don't use parentheses. We are not calling the function. We are putting the function shout into the variable screen. It means you can then call shout from screen. Okay. All right. Great. More than that, I mean, this is technically also how callbacks work in Python, right? If I'm not mistaken. Like when you have a function that's expecting a callback, you pass in the function name to the callback. I mean, different places have different ways of handling that, or well, different modules, different frameworks have different ways of handling their callbacks, especially when there's additional like parameters involved. Because I remember there was a bit of a confusion, at least for me, when I was doing what is it called? Streamlit? Yeah, Streamlit. When I was doing stuff with Streamlit and I was setting up a callback for when a button gets pressed. The confusion wasn't with how I can call how I can set up a callback function. The confusion was, if I remember right, it was with how exactly data gets passed in, because I think we had to pass in data as like a as a keyword arguments dictionary. Though I think, I mean, maybe I'm just remembering wrong. Maybe my confusion there was actually with how keyword arguments work. Because around that time, I was also learning, I was also like properly solidifying my understanding of um, positional arguments, position or keyword arguments, argument lists, and keyword argument dictionaries. I forgot what they're called exactly. The last thing, it's I think it's called keyword argument dictionaries. Yeah, I don't remember. But basically the idea is that you can pass like an arbitrary number of arguments to the function as long as it accepts that kind of an argument. You can pass an arbitrary number of arguments to the function without having to explicitly define the arguments in the function definition. So that way you can use that same function for various purposes. It can become a little bit messy if you don't keep track of exactly what you are expecting in terms of data or in terms of arguments. But as long as you're able to keep track of it, you can use that same function for multiple purposes. And I have actually done that. Multiple other frameworks also do that. I'm trying to remember which one was it. Was it Streamlit that I had seen this in, or some other framework? There was another one that I was looking into, Gradio. Yeah, I think I don't remember which, but there's a couple of them that do it. They take in like extra keyword arguments if you want to pass something in, and that way you're able to pass in arbitrary data that you may want to, how do I say this? Arbitrary data that you may want to pass in to customize something. Anyways, let's get back to this. More than that, it means you can remove the old name shout. Hold up. What just happened? Okay. You can remove the old name shout and the function will still be accessible from scream. Oh, that's interesting. I didn't know that. Wait, how does that work? Cuz my understanding was that scream contains sort of a reference to shout. But if you're deleting shout and you're still able to access scream, that means it's not a reference. It's somehow copying this. Okay, keep this in mind. We'll circle back to it shortly. Another interesting property of Python functions is they can be defined inside another function. Yeah, okay. Nested functions basically. Yep. You can call talk that defines whisper every time you call whisper. No, every time you call. Oh, there it is. Every time you call it, then whisper is called in talk. But whisper does not exist outside of talk. Okay. Function references. Okay, still here. Now the fun part. You've seen that functions are objects Therefore, functions can be assigned to a variable and they can be defined in another function. Okay, that means that a function can return another function. That makes sense? So we have shout, we have whisper, we are in get talk. So then we can return shout or whisper. Okay, all right, great. Get the function and assign it to a variable, talk. Okay, you can see that talk here is a function object. All right, it says function shout. Oh, it's because the default argument is this. Okay, that's it, right? That's the reason. Hold on, talk is a function object, but when you print out talk, it's a function object that's pointing to shout. It's not pointing to get talk. That's okay. We don't use this. We are not calling the function. We are returning the function object. Okay. All right. See, I'm confused over here because even here we are not calling it, but then the function object is pointing towards what exactly it's supposed to be returning. So that function object is then pointing towards the function object that it's supposed to be returning. The object is the one returned by the function. So if we call talk, talk returns the object. So when we call talk, instead of returning that function, it's directly calling the function that it's supposed to call. Okay. All right. Capitalize is in shout. Okay. All right. That's interesting. Okay. And you can even use it directly if you feel wild. Oh, hold up. That's crazy. So we call this and then we pass in an argument and then holy shit. We pass in an argument and then whatever is returned from this, we are directly calling that function here, which is why it's calling whisper. That's crazy. I don't think I've ever done this. I don't think I've ever done this. There's more. If you can return a function, you can pass one as a parameter. Yep. Okay. Well, you just have everything needed to understand decorators. You see, decorators are wrappers, which means they let you execute code before and after the function they decorate without modifying the function itself. Wait, they let you execute code before and after the function they decorate without modifying the function itself. All right, so handcrafted decorators, how you do it manually. A decorator is a function that expects another function as a parameter. All right, inside the decorator, wait, what is this function? This is a decorator. Inside the decorator, no, inside the decorator defines a function on the fly, the wrapper. This function is going to be wrapped around the original function so it can execute code before and after it. A function to decorate, is that the oh that's the argument. Okay, all right. So it's going to do something here and then it's going to call the function and then it's going to do something here. Okay, at this point a function to decorate has never been executed. Wait, that's interesting. Oh, we are outside of this. So it hasn't been executed because this hasn't been called yet, right? Is that yeah, that's right. That's right. This hasn't been executed yet. So that's why this function hasn't been called yet. Am I understanding that right? hold on. Okay, let's just go along with this. At this point, a function to decorate has never been executed. We return the wrapper function we have just created. The wrapper contains the function and the code to execute before and after. It's ready to use. Now imagine you create a function you don't want to ever touch again. Okay, a standard so-and-so, it outputs so-and-so. All right. Well, you can decorate it to extend its behavior. Just pass it to the decorator. It will wrap it dynamically in any code you want and return you a new function ready to be used. Wait, so that is our thing. Okay, and then we do this, and then we call that. Okay. So the basic idea is that you have a function that takes in a function as an argument, and within that function you have, so let's call this function A. So within function A you have function B, which executes certain code and then calls the function that you passed in as an argument and then executes some more code. Okay, so function B is what gets returned by function A. And that's the whole idea behind a decorator. All right, okay, that's interesting. So it's just a concept. Now you probably want that every time you call a standard function decorated is called instead. That's easy. Just override a standalone function. Have I been saying a standard function? I think I've been saying a standard function. Whatever. Okay. Now you probably want that every time you call a standalone function decorated is called instead. That's easy. Just override a standalone function with the function returned by my shiny new decorator. Okay. All right. Decorators demystified. The previous example using decorator syntax is this. That's crazy, dude. Hold on. Hold on. That is crazy. Wait, so if I've. Okay, so that's what they meant when they said this, because it's my shiny new decorator. Um, Another standalone function equals so and so. So the whole idea with the decorator, if I'm able to recreate this example, let's recreate this thing. Actually, let me hydrate first. After that, I'll recreate it. Okay. Um, my VS Code froze for a little bit, and it still seems to have some remnants of that freeze. So give it a couple of seconds, I guess. Okay. All right. I think we're good. Yeah. All right. So let's create a function called Okay, it's still stuck for a bit. Give it a second. But this is interesting, dude. So now it's slowly making sense. Like they were mentioning earlier that it's basically syntax for like if you create an object and then um you assign to it the value returned by a function to which you have passed in this same object, and then whatever is returned by that function, which is also a function object, you are then able to call that. Okay, so let's say my decorator o1, okay, and in here we are going to pass in some func o1, and here we're going to say my decorator. No, what should I name this? I don't know, decorator things. Right? So wait, would I be able to access this instant? Am I supposed to pass in this thing as, because like, okay, hold on, let me find out. Yeah, would this work? Okay, so if we are passing in something here, right, so function arguments work a little differently. Okay, so let's say a equals 5. Would I be able to access a here? Okay. There was a thing in Python where if you were passing in data, you had to declare something. There was global and there was something non-local. Hold on. A equals 5. Let's keep this aside for now temporarily, and let's print out a over here. And then in here, I want to call decorator things. Are we good? I think we're good. Yes. So then here we call my decorator, to which we need to pass in a function. Let's get rid of that temporarily. Okay. So what does that print? That prints 5. Just for the sake of, okay. All right. So what exactly was it then? I can't remember what the thing was where, like, there was a thing that I had to, that you have to keep in mind when you're coding in Python, that the variable doesn't automatically like transfer over. It gets treated as something different. So I guess if I tried to do something like this, a equals a plus 5. Let me just see if that helps me reproduce the example. I think I reproduced it because a is not defined. Cannot access local variable a, which is not associated with a value. Okay, yeah, that's what it was. So now what I'm wondering here is, would the same apply to some func? Actually, I should try passing in a function argument and see if it applies then. But yeah, the idea here, I believe, was non-local, right? You have to do non-local a, and then we are able to get the thing. So if I declare non-local a, then it's gonna, then a still has the value. So we're still treating A as this A. And so then when we do, this, then it works. I just clicked on something and some stuff is happening. Okay. All right. Cool. All right. Uh, by the way, let me just confirm that the music is still going. Holy shit. I have way too many of these open. I think that might be causing a bit of a slowdown. So let's close a bunch of these because I'm already getting my answers for, oh God, I have opened so many tabs. Hold on, dude. Let me close a bunch of these. Here I need to close these tabs. Yeah, okay, I can open them. I can open them up later. Right. Why did I open this in the first place? Oh, it was to check. Okay. All right. Cool. So, what was I gonna yeah, I was gonna do this. Okay, great. So, now would this work? This actually I have to pass in, let's say 5. Right, that does not work. Right? Because it's still non-local. And if it's non-local, well, no, but it's still local. I need to make it non-local, and then that should work. Okay. That being said, I think the same thing would apply to some func as well, right? So I would not be able to do this. So let's say define what something O1, and this prints out something O1 called. And then in here, I want to pass in, oh shit, what did I just do? I just hit some key that I don't think you guys are able to see it, but down here in the status bar, it activated some kind of magnet. Oh God, hold on, hold on. Let me take care of this thing, whatever is going on here. Let's reduce that. Let's zoom out. That's the word I'm looking for. Okay, all right. How did I do that again? Let me just. Well, usually the way to do that is oh, yeah, so zooming in is control plus and then zooming out is control minus. When I hit control backspace to delete, I think I was trying to delete the word. I accidentally also hit the plus key because that's right next to backspace. Okay, I think that's what happened. Okay, anyway, so we're gonna pass in something O1 and this should get the thing done for us, right? Also, I'm not trying to do this. I'm trying to return this function. Isn't that right? I'm trying to return this function because the function doesn't have to be. Does the function have to be called? Let me just make sure. This is interesting, dude. We were supposed to be looking at socket select and all of that stuff, but like I'm really interested in this right now. So we're gonna be doing this. Handcrafted decorators. Okay, okay. All right. So we are returning this function. We are returning this function object. All right. Um, let's also do something here. Let's say decorator things start, and then decorator things end. All right. So now when I run this, it should first say decorator things start, and then something O1 called, and then decorator things end. That did not happen. Okay, hold up. Hold up. So, something O1 equals this. Okay, and then we call something O1. All right, that's interesting. Okay, hold up. Okay, so all right, hold up. So instead of doing this now, right, so now if I just call something O1, then the decorator is not being called. So now we can, oh God, what did I do? Come down here. There it is. Okay. So now we can use that decorator, whatever, wrapper, syntactical sugar thing. I think it's my decorator O1, right? So if I use this, then I should be able to pass in, okay, there it is. So this is how decorators work. That is crazy, dude. That is crazy. Dude, this is something new for me because I haven't done this before. Like, I knew about being able to pass in functions as arguments. I knew to a certain extent that functions are objects in Python. In fact, I was mentioning this in the last stream as well, that like a lot of things in Python are objects, including functions. And so you're able to pass in functions as arguments. You're able to assign functions to something else and then call that something else as the function instead. You're able to do a bunch of different like interesting things, but I've never actually done this. I've seen decorators being used, but I had no idea how exactly they were working. And this is kind of interesting to me because like, okay, so let's take a look at what's happening here. How exactly is this working? Like this line here, this statement, what is this doing? Because if I create a function called num01 and then I create a variable called num01, what's going to happen? Like if I print out num01 at that point, the value has been overwritten. So it's no longer a function at that point, right? So if I try to call it as a function, that doesn't work anymore because it has been reassigned, and as it mentions here, it is not callable. Right, so then what is happening here is that we are reassigning this to be, oh, we are reassigning this to be connected to or to have a reference to this decorator method. To we are reassigning this to have a reference to whatever is returned by this my decorator function. And because this my decorator function itself returns a function object, that is why we are able to then call something O1 as a function itself. Because now this is now pointing towards whatever is being returned by the decorator. That is crazy, dude. Wait, so okay, so at this point we have called this function. We have called this function, and in this function we have this function defined, this object defined, this function object defined, or well, we have this function defined, which is a function object, and then we are returning the function object as a result of this function. But what's interesting is the function, even though we have left this function at this point, because we have a reference to this function, through the function object, that's why we're able to call that function. And then this is basically syntactical sugar for, well, this. That's crazy, dude. Yo, we learned something today. That's crazy. Hold on. Is there more to this? What more does this thing say? Decorators demystified. The previous example using decorator syntax is so and so. Yes, that's all. It's that simple. At decorator is just a shorthand to this. Okay, yep, that's what we just did. Okay. Decorators are just a Python. Oh shit, I missed the add timer. Okay, so there's going to be an ad playing in a couple of seconds, I guess. I'll let you guys know when it's playing. Okay, decorators are just a Pythonic variant of the decorator design pattern. There are several there are several classic design patterns embedded in Python to ease development, like iterators. Of course, you can accumulate decorators. What does it mean to accumulate decorators? Uh, hold up. Um, oh, is it like decorators inside decorators? Wait, hold on. Something else that I didn't take into. Oh, yeah, wait, no, hold up. So, okay, let's hold up for 30 seconds, I guess, because there's an ad playing right now. So I'm going to take a little hydration break. Okay, so yeah, earlier I was about to say something about like I was having a slight confusion about how exactly we were able to pass in this thing when it is being assigned over here, but then I remembered that it is already defined here, and that is why we're able to pass that in while reassigning the thing. Okay, great, awesome. Using the Python decorator syntax, it would be so and so and so. Oh, wait, you can like stack decorators? Oh, that makes sense, doesn't it? Because like you could then pass that into multiple. You could then pass that in. That actually becomes shorter than what you would otherwise have to do. Because otherwise, these two lines would instead be four lines. To be fair, even if we were using one decorator, instead of one line, it would be two lines. Because you would have to reassign the value of that function name, right? Or, well, you would have to reassign the value of the variable that has that same name as a function, and then you have to actually call the function, which will now be calling the function that is returned by the decorator. This is crazy. There's like multiple levels to this. Okay, the order you set the decorators matters. Okay, all right. Now to answer the question, as a conclusion, you can easily answer the question. The decorator to make it bold, the decorator to make it italic. Dude, prior to actually hearing people say the word italic, I didn't know that it's called italic. And to be honest, I still don't know if it's called italic because like growing up, we just called it italic. We didn't know what it was. Like we were going based off of, Italian. So you're like, oh, okay, maybe it's called italic. But then I heard people saying italic. So I was like, okay, maybe it's that. But to be fair, um, italic was also coming from people who say Iraq instead of Iraq. So that's why I don't know if it's the accurate pronunciation. I need to look this up. I need to look this up to see what exactly it's called. Because like we just used to say italics, but like we didn't know exactly what the pronunciation was. Either way, okay, italics. Let's just go with that. Uh, so we have a decorator for bold. We have another one for italic, and then uh, we have the decorators being used in say. Hold up. So we have the decorators being used in say, and then we are calling say. So at this point, if we are calling say has already been reassigned. No, has it? No, wait. Hold on. Hold up. This becomes one line. Earlier, when I was talking about it being two lines, it is not two lines, right? Well, no, I was saying two lines for this. Okay, I wasn't saying two lines for the actual call. Two lines here versus. So okay, it's not two lines. I was not counting this. So it's not two lines, it's three lines. Because like even in the other situation, we would then be assigning twice and then calling. Okay, no, hold on. So if we had two decorators here, um, and then we try to call. So if we have two decorators here and then we try to call this, these two decorators are. Because like, let's say if I mean, I don't have a second decorator, but like, let's say I did have a second decorator, right? I would have to do this. Isn't that right? Like, let's say I'm not using this syntactical sugar. I would have to do something like this. However, if I did this instead, then when I called this once, what would happen exactly? I'm getting kind of confused here about like, okay, hold up. So let's get rid of this. Okay. And we can get rid of this. Okay. So this line is sugar or syntactical sugar for this line. Okay, cool. Now let's say we have a second thing, right? That would then be reassigning, wouldn't it? I need to test this out. I need to test this out right now. So let's create a second decorator. Uh, and we can just, so let's give proper, so we have, okay, so my decorator O1, decorator things, my decorator O1, okay, cool. Then we have my decorator O2, and we can add that here and add that there. Okay, awesome. So at this point, if I do this, how exactly would this be working? Would this internally do basically this, or would it do this? Because there's a big difference between the two, right? If we assign this first and then call it as a function, we are then calling that function, right? But if we assign this and then reassign it, now we have the function, now we have this variable pointing to like a different function. It's not pointing to the same function. So like, you get what I'm saying? It's gonna have, it's just gonna be one function call. Though, okay, so let's see what's happening here. Oh, that's interesting. Um, so I'm guessing that's what this example was demonstrating with like the whole whatever ham and cheese sandwich thing. Uh, okay, okay. We need to understand what's going on here. So we pass this in. We're calling this once, right? This would be different from calling it, oh God, not, oh wait, no, hold up. Um, Wait, why did that just happen? I had these three. How did that, okay, anyways. So let's get rid of these two and now voice crack. Holy shit. Now do the thing. All right, that's interesting. Oh, um, right. So I just realized that this is becoming a nested function kind of thing. Well, it's adding an extra layer of nested function because like it's, hold on. I need to, okay. All right. So, okay, let's take a look at what exactly is going on here when I do it in this way. And I think this might not be what's happening. I think this is what's happening because like how do I achieve the same result as when I was using the syntactical sugar? I think this is the same result, right? And something important to notice is that my decorator O2 is being called first. So that becomes sort of like the outer shell. And then we are calling the inner shell, and then we are calling the actual function, right? So let's take a look at what's happening here, because if this is supposed to be syntactical sugar for this line, right? So we are creating a variable, or we are reassigning. We are reassigning the value of something O1 to be a function returned, or a function object returned by my decorator O1. And into my decorator O1, we are passing in something O1, which is currently a function. Okay, so at this point, something O1 is holding the value. Something O1 is basically the decorator function that's within my decorator. All right, okay. So if we go to the next line and then we assign this, and then we pass in this, now what we are passing in is the decorator function. Okay, now we are passing in the decorator function, and then we are returning this. We are not returning this because this was returned at the first thing. The second thing returns this. And so because of that, now if we trace the thing back, when we call this, this is pointing towards this decorator things. And so that calls this, which is my decorator O2, decorator things start. And then we call sumfunc O1, which is currently this decorator things. And this is currently, okay, so then that prints out this line, and then it calls sumfunc O1. So what's interesting to me here is that throughout all of this, we are like, it is still able to, it is still like holding the references. Even after we've done like a bunch of reassigning, it's still holding the references. Or rather, it's not even about reassigning. It's like even after the function has exited, right? The function exited and it returned this. But then this somehow, like, how does the function know that this is supposed to be pointing to this? I think, yeah, no, dude, I need to understand because, like, I mean, that's being stored somewhere. Obviously, that reference is being stored somewhere. It doesn't just lose the reference, but that's kind of interesting to me, thinking about like, okay, it still has that reference. It's still stored somewhere. We have exited the function. We have exited this function, right? And this function has exited and returned this. We are no longer calling this function specifically, but at a later time, we're going to be calling this function. And in this function, we are calling this function, which is this function object. But even though we have exited this function, we still know, or Python still knows, what this is pointing to, or rather what this is supposed to be pointing to when we at a later time call this. So this is all being stored somewhere. I need to look into like how how exactly that's working. But okay, that kind of like, well, demystifies it for me. All right, cool, cool. Good to know. Good to know. So we learned about decorators today. That's exciting. What more is there here? Okay, so we did this and we did this. So when we do this, it's going to first do this and then do this. And okay, okay. Oh, wait a second. I did not think about doing this. I was instead doing it on the next line. Could we, accomplish the same like stacked behavior if we did it in that way. So let's try decorator 1. How should it be? Okay. Decorator 1 and then decorator 2 and then that. Okay. So what result does that give us? Okay, so that puts decorator 1 on the outer shell because that's exactly what we have done, right? And then if we change the thing, then it goes back to the way it was. You can now just leave happy or or burn your brain a little bit more and see advanced uses of decorators. Taking decorators to the next level, passing arguments to the decorated function. Okay, all right. Right, so how would you go about passing an argument here? You would have, oh, so the wrapper function would have to have the same number of arguments as the function that you are trying to wrap or the function you are trying to decorate, right? That makes sense. And so because of that, when you do this, though, okay, does it implicitly pass in the argument? How does it know what arguments to, like, how does it know which arguments to connect to which arguments? Like, I don't know if I'm asking my question right, but like, okay, let's say num o1, let's say arg o1. Okay, let's say something o1. And then, I don't know, this prints out arg o1. Great, awesome. And then here, let's say something o2. This takes in arg o1, but this calls arg o1. Because the assumption here is that in something o2, we are passing in the thing as an argument. Okay, what was I trying to do by creating this example? I forgot. Okay, hold on. Let's just go with this. Um, where was I going with? I was trying to recreate an example where we have a function that takes an argument, and then we have another function that takes in this function as an argument. No, we have another function that takes in, well, yeah, this function as an argument, and then we call, maybe I should recreate the thing with decorators specifically. Because, like, okay, hold up. So we do something o1. Um, we don't call something o1. We call something o2, right? And so then this is supposed to return this. Okay, all right. And then in here, we call something o1. And if I call this, would this work? All right, so this prints out this. So here we have a reference to this, right? This function, and then this function takes in these two arguments, so that's why we're able to do that. All right, what if I do this? This should throw an error now, right? Yes, because incorrect number of arguments. There you go. Okay, all right. Okay, cool. Right, so we are able to pass in arguments. Then we have decorating methods. One nifty thing about Python is that methods and functions are really the same. The only difference is that methods expect their first argument is a reference to the current object. Okay, so yeah, methods are associated with a class. Well, methods are usually functions that are on an instance of a class. I think that would be more accurate to say. I don't know. Okay. That means you can build a decorator for methods the same way. Wait, isn't that what we were doing earlier? Weren't we creating decorators for methods just now? Like, oh no, we were creating them for functions. Now we can do them for methods, meaning it's on a class. It's a decorator for a method, which is a function that's on an instance of a class. Okay. Just remember to take self into consideration. All right. Okay. Oh, okay. So in here we pass in self. Okay. Okay. Cool. All right. I'm getting a little lost here, but like I'm kind of getting the idea. So here we're able to add this method decorator, and the only difference I'm seeing here is that we are using self. So we are then also able to pass in the instance of the class, or instance of, yeah, instance of the class, right? And isn't the instance also being used? Yeah, I think it's being used here. Okay, all right. If you're making general purpose decorator, you'll apply to any function or method, no matter its arguments, then just use args. All right. Okay. Yeah. So this is earlier I was mentioning about arguments list. This is an arguments list, and this is a keywords dictionary or keyword args. So this is basically a dictionary that you can pass in with like arbitrary number of arguments. The difference between arguments list and the keywords dictionary is with an arguments list, it's just a list of values that you provide, and with the keyword args dictionary, it's basically it's a dictionary, so you're able to associate a key with a value, or a name with a value, and so that way you can like that way it becomes a little I was about to say it becomes a little more meaningful, but like that's not the right word to use there. Basically you can then access it through a key as opposed to accessing it through the index. as you would need to do with argument lists. Okay. Um, okay, I'm gonna get lost reading all of this. So I'm not gonna go into it. All right, passing arguments to the decorator. Great. Now what would you say about passing arguments to the decorator itself? Passing arguments to the decorator itself. So without the syntactical sugar, I can see that happening. But like in terms of like if we are using the syntactical sugar, would we just add parentheses there to pass in the arguments? Um, this can get somewhat twisted since the decorator must accept a function as an argument. Therefore, you cannot pass the decorated function's arguments directly to the decorator. Before rushing to the solution, let's write a little reminder. Right, so that's a decorator. Okay, okay, great. It says decorator with decorators are ordinary functions. Okay, cool. Therefore, you can call it without so and so. That makes sense. And then this is a lazy function. We can pass in the lazy function as an argument to the decorator. Okay, it outputs so and so. All right, great. It's exactly the same. My decorator is called. So when you use so and so, you are telling Python to call the function labeled by the variable my decorator. Okay. This is important. The label you give can point directly to the decorator or not. Let's get evil. All right, let's do that. So this is a decorator maker. And then here we have here we have the decorator inside the decorator maker, and inside the decorator we have whatever the wrapper function is. So the decorator is returning the wrapper function object, and then the decorator maker is returning the decorator. So now you would be calling the decorator maker instead. All right, then we decorate the function. Okay, all right, no surprise here. Let's do exactly the same thing, but skip all the pesky intermediate variables. Okay, all right. Let's make it even shorter. Okay, cool. We used a function call with so-and-so syntax. Okay. I make decorators. Okay, all right. So the idea is to wrap the decorator function into a decorator maker function. So you are then able to pass in that. Wait, though, how are you able to use, hold on, go back. How are you able to use, oh, so far we are not passing in a value. Okay, we're probably going to get to that part. So back to decorators with arguments. If we can use functions to generate the decorator on the fly, we can pass arguments. Actually, wait, hold on. Are we generating the decorator on the fly? Decorator maker. Okay, so then, oh, I just realized something. We are not using like how are we getting this to work? I just realized that. So new decorator equals decorator maker, but it's equal to the function call, and that returns the decorator. And then we have a decorated function, and decorated function equals new decorator, decorated function. But new decorator is now equal to the decorator, not the decorator maker. And so that returns that function. That returns the wrapper function, which you can then call. But like, oh yeah, okay. Because we are passing in the decorated function. So then we are calling the wrapper, right? And that outputs the wrapper. Okay. All right. And so because of that, we wait, so what's going on here? Decorated function equals decorator maker. We call decorator maker, and that returns the decorator to which we are passing in the decorated function. Wow, there's levels here. Holy shit. And then we are able to call the decorated function because that is then pointing to the wrapper function. And then we make it even shorter using the parentheses. All right. Okay. Right. So in the decorator maker, we are able to pass in arguments, but those arguments don't get passed into the decorator itself. So that's decorated arguments. Okay. Wait, do they get passed in here? Because it says decorated arguments, but like, how are we able to use these arguments in here? Because this is like one level in, right? The ability to pass arguments here is a gift from fuck's sake, dude. My mouse wheel is just okay. The ability to pass arguments here is a gift from closures. If you're not comfortable with closures, you can assume it's okay. Or read so and so. Don't confuse decorator arguments with don't confuse decorator arguments and function arguments. Okay, I'm still wondering like how. Okay, let's read this. Well, I'm not going to read it like on stream. I'll definitely read it off stream. Um, okay. All right, so then we are able to pass in values to the decorator. I'm still confused about we are able to use how we are able to use decorator arguments 1 and 2, which are passed in as arguments, but they're within the scope of this function. How are we able to use that within a nested function? And I'm not seeing any like non-local or anything like that. Like, how's that working? Or is there something special going on just because it's a decorator? Okay, so I'm gonna look into that later. But I also just noticed something here. We are passing in two arguments here, but then we are passing in two arguments here as well. Oh, is this going to the, I think this is going to the wrapper function. Okay, okay. So I guess that's why they were saying don't confuse the, yeah, yeah, there it is. From the decorator and from the function call, yeah. Which, okay, that's interesting, because like, that means that even this nested function is now able to access whatever is up here. So I definitely need to understand what exactly is going on here. Here it is, a decorator with arguments. Arguments can be set as variables. Okay, okay, all right, cool. Great. Let's practice decorating a decor. Oh, wow, this goes on for a bit. How can decorators be useful? I can I can for sure see use cases. Um, oh, that's crazy, dude. Yeah, shout out to this person and probably the multiple people that helped, you know, uh what's the right word to use here? The multiple people that probably helped make this answer better, because like people might have contributed their point of view on it as well. They might have given feedback that this can be improved, that can be improved. Either way, dude, holy shit, this is helpful. This is super helpful. I'm gonna carry on reading this thing, but in the meantime, okay, you know what? We are gonna go. Um, okay, I was thinking of rating someone, but like I'm not sure who to rate right now. All right, you know what? Cool. We are gonna go raid this person named Tiger Chimera. I hope their raid settings allow for one person raids. I don't know how many people are there. Okay, it allows. Great. Awesome. Cool. So, yeah, that's going to be it for today's stream. Uh, I'll try to stream again tomorrow. At the very least, I'm going to try and do a mute stream, if not a proper, talking stream. But yeah, that's going to be it for today. I hope you guys have a nice day, and I will see you all next time. Peace.